Welcome to this video on solving and justifying literal equations. By the end of this video, you should be able to solve a literal equation for a given variable, and you should be able to justify the steps for solving a literal equation using the properties of equality. Alright, so let's do a quick review. Here on the left, we have a two-step equation. We want to get x alone. So this says solve each of these for x. So here's x in this term. But there's two terms on that same side, so we want to get it to one term so we can get x alone. So we should add the 5. So we're trying to get that x by itself. These cancel to 0, and I'm left with 2x equals 18. Now this is 2 times x. To undo multiplication, you divide, so we're going to use the division property on both sides. 2 divided by 2 cancels to a positive 1, leaving x. 18 divided by 2 equals 9. Okay, so we've done this. That was a two-step equation. We had to do two things to get x alone. Over here, look at the difference. This is all letters. We had letters and numbers going on here. So, but I can use the same properties of equality to get this x alone. So here's the x inside of ax. There are two terms on this side, and there can only be one term. So I'm going to do the opposite to move the opposite operation to move the b to the other side so I can work and get the x alone. So that's a negative b, so I'm going to say plus b. And plus b on the other side of the equal sign. These b's cancel out to 0 because negative b plus b is 0. And I have ax equals, now c and b are not like terms, so we can't combine them together, but we can write them as c plus b. Okay, now we're still trying to get x alone. This is a times x, so the opposite operation from times is division, so divide by a, and we have x equals c plus b divided by a. So we use the same process in both of these equations. This is a special kind of equation called a literal equation, which is an equation that contains more than one variable. All right, so what are some ideas here? How are these two guys the same? Well, one of the ways they're the same is we used opposite operations to isolate the variable. Okay, so here that was minus 5, so we added 5. We used an opposite operation. This was minus b, so we added b. Opposite operations to isolate the variable. But how they're different is in literal equations, all the terms won't combine because they're not like terms. So sometimes it feels a little messier because we're not combining terms along the way. So what we're going to do is we're going to solve some equations for a given variable, and we're going to use our justifications, our properties of equality that we've been using to justify the steps that we're going to take. So remember, our first justification is always given. That's the problem that's given to us. So we'll go ahead and write given in on here so we don't have to worry about it. Okay. So we have A equals LW, and we want to get W by itself. So on this side where W is, there is only one term. There's no addition or subtraction, so this is one term. L is multiplying to W. So to undo that multiplication, we have to do the opposite operation, which would be division. We want the L to go away, so we're going to divide by L on both sides. What tells us we can do that is our division property. Now here's where we're talking about that things are not going to combine. A and L are not like terms, so we're just going to write A divided by L because I can't combine them down any. This L cancels with the L below it to 1, leaving W. And that's our answer. A divided by L equals W. So we're just rearranging. Usually this is used, especially in science, with formulas, that you rearrange the formula for a given variable. So let's try it again. We have A equals BH, and we want to solve for H. So here's your H, and it's tied up in this term. This is the only term on this side. So I don't have to add or subtract anything because there's no addition or subtraction going on over here. However, I do have multiplication because this is really B times H. The opposite of multiplication is division. Now I want H to stay there. I need B to move away, so I'm going to divide by B. Okay. So when I go to write this down, A and B are not like terms, so I'm going to have to leave them apart. A divided by B equals, the B cancels to a 1 and leaves the H all alone on that side. And the reason we're allowed to do that is our division property of equality. Okay, so let's try it again. D equals RT. Distance equals rate times time. This is an actual science formula. This is area equals base times height. Those are science. Area equals length times width. Okay, these are all formulas that we can be using in science and math. I want to get the t, the time, by itself. So t is in this term right here. It is the only term on this side. Notice there's no addition or subtraction. So this is really r times t. So to undo multiplication, we have to do division, the opposite operation. We want t to stay put, which means the r needs to move away, so we're going to divide by r to get that r to cancel to 1. D and r are not like terms, so we're going to leave them separate. D divided by r equals, well, the r's cancel to 1 on that side, leaving just the t. And the reason we're allowed to do that is our division property. Okay, so that's not, the division property is not the only thing that can be used. Let's flip this over and try some of these on the back side. All right, so let's take a look at number 4 here. Number 4 is actually the standard form of a line. AX plus BY equals C. So this is going to take a little bit more steps, but we want to get y alone just like we were doing when we were putting our equations into slope-intercept form. There we had numbers, this time we don't. That's the difference. So remember, our first step, the problem was given to us, so these are all givens. Okay, so we're trying to get y by itself. So here's y. It's tied up in that term, and you'll see that there's 2 terms on the side. Well, you can only get to y when there's only 1 term. So that means I need to move the ax over. This is a positive ax, so I'm going to subtract ax from both sides of the equation. And the reason I'm allowed to do that is my subtraction property. Okay, ax minus ax cancels to 0. And what's left is I have by equals, these are not like terms. I cannot combine them, so I'm just going to write c minus ax. Okay. Now, we're still trying to get y alone. We have b and y. This is b times y. So to undo multiplication, we're going to use division. That's the opposite operation. You need y to stay put and b to go away. So we're going to divide by b. And we're allowed to do that because that's our division property. Okay. B divided by b cancels to 1, leaving 1y. None of those are like terms, so we can't combine any of them, so we're just going to bring them down. C minus ax divided by b. That's going to be our final answer there. So that's the big thing. Because they don't combine down or reduce, because they're not like terms, you tend to have everything remaining in your final answer that you started with. It's just in a different position. All right, so let's try it again. So this is perimeter equals 2 times the length plus 2 times the width. And we want to get the width all by itself. So we need w by itself. Here's w. It's tied up with this 2 in this term. But there's another term on the same side. So you remember, you cannot get into this w until you move the other term over. That's a positive 2L. So let's subtract 2L from both sides of the equal sign. P minus 2L, those are not like terms, so we're just going to write it P minus 2L equals, well, 2L minus 2L on that side canceled to 0, so that's gone, leaving just 2W. Okay, now we need W alone, and currently it's 2 times W, so to undo the multiplication, we're going to divide by 2, the whole thing, and we're allowed to do this. Well, our first step was we forgot to write it down. That's our subtraction property, was the first thing that we did. The next one is our division property. Okay, so remember, this is really 2 is dividing to each of those. P divided by 2, those are not like terms. Negative 2L divided by 2, this is going to cancel down to a negative 1, so we're just going to say minus L, because the 2's cancel down to a 1, equals these 2 cancel to a 1, leaving the W by itself. Right? So it can be a little confusing. You really need to show all of your steps out and work slowly and leave room to show everything that you did so you kind of understand what's going on. Let's try this again. So we want to get B by itself. Here's B. This is really one term because there's nothing adding or subtracting to it. So B is in this term, but I can't deal with it in its fraction form. I need the fraction to go away, which means I need that letter D to go so I can get rid of the fraction. So currently the D is dividing. This B plus C is divided by D. So the opposite of division is multiplication. So if I multiply this side by D, I'm going to have to multiply the other side by D, and that's, remember, our multiplication property. So what's that going to give us? D times A, well, those are not like terms, so I'm just going to write them in alphabetical order. A times D equals, well, this D is going to cancel to a 1 with that D, leaving B plus C behind. Okay, now remember, we're trying to get B alone here. Here's my B. I have a plus C going on over here because I got 2 terms. I don't want the plus C, so let's move the plus C. Do the opposite operation, minus C. And we're allowed to do this because of our subtraction property. Okay, AD minus C, none of those are like terms. So we're going to write AD minus C equals, well, these C's cancel, leaving just the B behind, and that's going to be our final answer with that one. So you can see we still have all of the same pieces, they just get moved from where they originally are. It's not often we get to combine some like terms. So our last one here, 7, it doesn't say which one we want to solve for, so let's solve for H. Okay. Now, H is right there. Notice there is only one term on this side. There is no addition or subtraction, so LWH counts as one term. So this is really L times W times H. We got a lot of multiplication to go. I need H by itself. These are all multiplying together, so I can move them with the opposite operation of division. And what's nice is when it's one term like this and they're multiplying, I can do them both at the same time. I want L and W to go away to leave H by itself. And so this is L times W times H. So the opposite of the times is the division. So I'm going to divide this side by LW also. And the reason I'm allowed to do that is my division property. Okay. Now, V divided by LW, none of those are like terms, so we're going to leave it V divided by LW equals, well, the L's cancel and the W's cancel, leaving just the H there. All right, hopefully that was helpful for you. Let me know if you have any questions, and I'll see you in class.